Welcome to my experiences with EEGLAB so far. This is by no means meant to be a tutorial, and I profess no expertise in the use of this software. Rather, this is what I have discovered on my own over the past 2 weeks, and put this out on YouTube with the hopes that people that better understand this program can give me some input and advice. EEGLAB is a free open source EEG program that typically works in conjunction with MATLAB, a widely used scientific 3D graphing program. The full-blown program with the needed accessories MATLAB would cost about $4,000. There are student editions available for about $100. I've chosen to use the 182 megabyte compiled version that has some of the basics of MATLAB built into it, and it's totally for free. The EEG portion of the tools for the MATLAB are open source and apparently can be modified to your own needs if you have that type of expertise. I'm running this on Windows 7 Professional 64-bit operating system with 12 gigabytes of RAM on an Intel 920. You see that it's Windows 32-bit, but it works fine in this application. To load it up, it looks something like this. Ask you to run it, and then it puts this little DOS type box up here. It takes a little while to load everything. If you want help, they have a wonderful web tutorial. It's also available in PDF form, but the PDF form is about 211 pages long. Will offer a lot of explanation about how to use it. It's maybe a little too comprehensive to be too practical for a beginner. Okay, the Emotiv Epoc Headset Research Edition allows you to save your data files in the EDF format. The first thing one needs to do is import data, and we're going to be importing an EDF file. Now I will look here, and I've got an EDF file here with my eyes open about 3 minutes long. So one of the things I struggled with about 2 weeks is this channel list. Being a 14-channel EEG, I erroneously assumed that it would be channels 1 to 14. And what I was seeing is that my first channel, which is AF3, was really plotting the data packets, a very regular, strong signal, and perhaps everything else was skewed. Someone had given me the input that I really need to plot channels 3 through 16, and this works very well. So I've just created a little text file to allow me to copy and paste that in here. Okay, it wants me to give this a name. So we're going to call it Tom YouTube. Okay, one of the next things we need to do is we need to locate where the channels are. Under Edit, it says Locate Channels. Variety of options apparently to go in and coordinate where each one of these. I'm going to go Read Locations here, and what I'm going to look for is a CED file. You're welcome to use this one. It can also be extracted from the EDF file your Epoc headset puts out. When I do that, it gives me one extra column of all ones here, and I'll get an error message saying more columns than expected. Wiped out the last column, everything seems to work well. You can see the channel numbers 1 through 14 related to their typical labels, and then these are how they plot out on, shall we say, a spherical head to give the location. So when I go in here, I need to find this CED file. I load that up. File format, auto detect seems to work, and then OK this. Okay, now if I go to Tools, want to remove the baseline, was advised to do that, cleans things up quite a bit. And we OK that. And then Tools, I'm going to run ICA. And it takes a little processing, even with this computer here. We've got about 253 of these to process. So all my little Intel processors are busy just cranking out numbers, converting all those little wave signals into locations and colors, I guess. This might be painfully slow on a slower computer. Okay, we have that. Now we can go to plot. We can see where these channel locations are by name, see if we have that right. And here are the typical names. It's kind of handy. You can click it and it'll turn to the number. So looks like everything's lining up pretty much as the Emotiv Epoc headset does. You can also plot your locations out by number and have it look like that. So we seem to be doing as we should there. Now if I plot my scroll data, I get something like this. This is basically the same thing that's coming into test bench right here. And start looking through here, see if I see anything that really looks disturbing. There might be a little bit of a consistent bump here. I'll take that out. Obviously I've got something going here. So let's remove, I believe that's an artifact, extraneous noise. Okay, and we've got some stuff here. And a little blip here. Apparently there's a variety of automated tools and different filters that can take and plow off the tops or bottoms, or different algorithms can be applied to filter this out automatically rather than having to go through manually as I'm doing now. But this is a very early stage of my learning curve right here. Okay, we only have about 180 seconds. It was a 3-minute test. So I'm going to reject those areas I have highlighted.